Hi all, welcome back to Malware Analysis. I am J. Lavanya, Assistant Professor of CSE Department. In this video, we are gonna discuss on the topic that is build and debug the malware, file obfuscation, and binary obfuscation techniques. So let's dive into the topic. So first of all, what is file and binary obfuscation? As we have discussed in the previous video, what is meant by obfuscation and what are the techniques to be followed, what are the advantages, disadvantages, and what are the various types of obfuscation, right? And so today, this file and binary obfuscation or the techniques which is used to make some computer files and executable code that is difficult for humans and automated tools to analyze and understand. The goal is to hide some sensitive logic, protect intellectual property, and evade the detection by some security software. Okay. So first of all, what is meant by this binary obfuscation? Okay. So this binary obfuscation is or the method that is applicable to some executable files and binaries to make them more difficult to understand or to analyze or to reverse engineer while still preserving their original functionality. Okay, and mainly if you take this why we are going for these kind of file and binary obfuscator, that is protecting intellectual property. Developers may want to prevent the competitors from reverse engineering their software and stealing proprietary algorithms or the business logic. And second, preventing some tampering process. So obfuscation makes it harder for the attackers to understand and modify an application's code to change its functionality or add some malicious features. And third, like evading some security tools. So malware authors, they use this obfuscation to disguise some malicious payload and evade the detection by signature-based antivirus software. Sophisticated malware can use some polymorphism or metamorphism to change its code with some every iteration. And next, like hiding sensitive information. So obfuscation can hide some strings such as passwords, server addresses, and file paths that could reveal an application's secret. And some of the common obfuscation techniques, if you take, first of all, renaming. So renaming is a basic method that changes the names of the variables, functions, and classes to meaningless or misleading characters. For example, a function named calculate underscore user underscore score up. So that might be renamed to some A1, B2, C3 off, right? So this could be understand only for that particular, we can't able to mislead any kind of such functions. Okay, so that is what we are going for this kind of, obfuscation. And second one, control flow obfuscation. So this technique alters a program's logical structure that making it difficult to trace its execution path. And next, like opaque predicates. So these are conditional branches. So if then statements with an outcome that is always the same but is constructed in a complex way that is obvious to an analyst without executing the code. Okay, the result is that an analyst waste time trying to figure out why the code would ever take the other path. And next, like control flow flattening. So this technique restructures the code so that all basic blocks are directed to a central dispatcher node that uses some artificial variable to determine the next block to execute. Okay. This replaces a program's natural sequential flow with a confusing or tangled sophisticated code structure. And next, like if you go for some code and data encryption, so this involves encrypting some sensitive strings or anti-code sections within the binary. Okay, and the encrypted data is decrypted at runtime whenever it's needed, making its static analysis useless for that section of the code. And next, like string encryption. So this specifically hides the readable strings, example, a URL, password. So by encrypting them in the binary file. Okay. The strings are only decrypted in memory just before they are used. And like cryptos, so this technique encrypts and compresses the entire malicious executable. The crypto acts as a step that decrypts and unpacks the code into memory at the runtime, helping the malware to evade the signature based deduction. Okay, and anti-debugging and anti-tampering, so these methods also add the code to detect and disrupt the reverse engineering efforts. And first of all, debugger detection. The code can check for the presence of a debugger and alter its behavior, terminate or throw some deceptive data if one is detected. And next, tamper detection. So integrity checks such as cryptographic hashes that can be embedded within an application to detect some unauthorized modifications. If tampering is detected, the program can exit or corrupt its own data. And next, code insertion and transformation. So here how this obfuscation is used. So these techniques which add or modify the code to increase its complexity. First of all, dummy code insertion. The obfuscator adds some irrelevant or the dead code that does not affect the program's function but confuses an analyst by increasing the code volume. And next, like instruction substitution, simple CPU instructions are replaced with more complex or equivalent sequences that are harder for a human to interpret. Okay, so that is why they go for some kind of stuff where the analyst, like he or she, can able to analyze problem very quickly, or she can able to understand. Okay, and next, code virtualization. So this advanced technique transforms the sections of the original code into a custom instruction set that is then executed by a virtual machine that is embedded within the binary file. So this creates a powerful layer of abstraction that is very, very difficult to reverse engineer. Okay, so these are all which is the common for the binary obfuscation, right? And next is why should we go for this binary, or why it has to be implemented, right? So while we are implementing this obfuscation that enhances the software protection by deterring some reverse engineering and unauthorized modification. And second, if you are not implementing or not, it is not implemented, it reduces the development complexity, but it leaves the software vulnerable to analysis and compromise. Okay, so that is why the binary obfuscation has to be implemented. Okay, and next one, let us see what are the common binary obfuscation techniques. So first of all, it is code transformation. Second, data obfuscation. Third one, structural obfuscation. And last one, that is anti-analysis techniques. Okay. Yeah. So first one, the code transformation. So code, control flow patterns. So this technique transforms the program's control flow into a single complex loop within a dispatcher, that making it difficult to trace the original execution path. And next, like opaque predicates, These are the conditional statements inserted into the code that always evaluate to true or false, but that are computationally difficult to determine statistically, posing analysis tools to execute the code. And next one, a junk code insertion. So irrelevant or the dead code is added to the binary, that increasing its size and complexity without affecting its functionality. Okay, making it harder to distinguish the legitimate code from the noise. And next one, like instruction substitution under code transformation. So replacing some standard instructions with a functionality equivalent but less common or more complex instruction sequences, right? So that all comes under this code transformation. And second one, data obfuscation. So here in this data obfuscation, there are two methods. So first of all, string encryption. So encrypting some sensitive strings within the binary and decrypting them only at the runtime, preventing the static analysis from easily extracting them. And next of all, data encoding or decomposition. So here, representing some data values in a non-obvious way to hinder some static analysis. Okay, so what is meant by non-obvious way? So here, like example, breaking a constant into some multiple parts. There are some that runtime. Okay, all the stuff comes under these data obfuscation. And next one, structural obfuscation, packing or compression. So compression, compressing or encrypting the entire binary or the parts of it, which requires the loader or the decryptor stub to unpack and execute the original code at the runtime. Okay, and next is that virtualization. So transforming the native code into a bytecode for a custom virtual machine that requires a specified interpreter to execute the code, adding a layer of complexity for some reverse engineers. And next, like anti-analysis technique. So this anti-analysis technique, there are anti-debugging and anti-tampering, anti-VM, right? So all these topics we will discuss very detailed in unit 5, right? In short form, I'll just say what is meant by anti-debugging and anti-tampering, right? So implementing checks that detect the presence of debuggers or modifications to the binary and reacting by exiting, crashing, or altering some behavior. So these techniques are often used in combination to create a layered defense that increasing the effort required for successful reverse engineering or the analysis. Okay. So these all comes under the common binary obfuscation techniques. Okay. Okay, so that's all regarding the binary obfuscation technique. And next topic is that file obfuscation. So file obfuscation, it disguises a file's purpose or content to evade the security tools or human analysis, a practice that is commonly used by both malware authors and legitimate software developers. Okay. And next one. So what are the file obfuscation or categorization of some of the binary obfuscation technique that is used in file obfuscation? So first one, control flow obfuscation. So control flow obfuscation that enhances some security with some simpler methods. And second, like virtualization. So virtualization offers some high security with complex implementation. And third one, like layered obfuscation. So layered obfuscation is straightforward but provides some minimal security And fourth one, like instruction pattern obfuscation. So instruction pattern obfuscation, is complex yet offers some limited security. Yeah. And these are some of the common techniques of file obfuscation, right? So first one, disguising file types in appearance. Second one, code and data obfuscation. Third one, like evasion and anti-analysis techniques, right? So in this uh, techniques, that is first one, like disguising the file type and appearance, right? So these technique manipulate the most basic file characteristics to make a malicious file appear benign and harmless. And second, like file extension manipulation, a file is renamed with a misleading extension to trick the user into thinking it's a different non-executable file type. For example, an executable file .exe might be disguised as a document. And next, like file format abuse, attackers hide some malicious payload inside some legitimate and complex file type, such as PDF, Office document, or some archives that can be execute embedded scripts or macros when opened. And next, like polyglot files. So this advanced technique creates a file that are valid in multiple formats simultaneously. A single file might function as, both a valid image or a valid zip archive that allows it to bypass some security scanners that only checks for one file type. And next, binary padding. So junk data is added to the file to increase its size, right? The blotted file can then exceed the size limits of some malware scanners, that causing them to skip the inspection, right? And second one, code and data obfuscation. So these methods change the way a file's internal code and data are stored, that makes it more difficult to analyze as reverse engineer, right? And here there are some of the methods which is used in this technique. First one, that is string encryption and encoding. So this technique replaces plain text strings like API calls or the network addresses with some encrypted or encoded versions. Okay, a decryption or decoding routine embedded in the code is used to make the strings readable at runtime. And common algorithm that is used to include like page 64 and XOR, okay, and code packing and compression. A popular method that uses an executable packer like the UPX to compress and encrypt the malware's original code. At runtime, a small legitimate looking stub unpacks and executes a payload in memory, which makes it hard to detect with signature-based antivirus software. And next, like obfuscating script files or the malicious scripts, particularly those written in languages like JavaScript or partial or often obfuscated. So techniques include using some random, meaningless variable names and encoding the script's contents to hide its true purpose, right? And next, like data obfuscation, sensitive data within a file, such as cryptographic keys or configuration information, is hidden from a static analysis. So this is achieved using techniques like data masking, encryption, or tokenization, and it is also commonly used by some legitimate developers to protect the intellectual property. Okay, and last technique that is used in file obfuscation is that evasion and anti-analysis techniques. So they are often layered on top of other obfuscation method, like that can be like binary or string so many, like obfuscation, right? To actively prevent some deduction and the analysis. The first one, anti-debugging. The code contains logic to detect if it is running in a debugger or the sandbox. If it detects an analysis environment, it may stop executing or changes behavior to appear harmless. And second, timing based evasion. The malware may include intentional delays before executing its payload. So this allows it to bypass the sandboxes, which only absorbs a file for a short period, right? And next, polymorphism and metamorphism. So advanced malware can change its code structure with each new infection. So polymorphic code uses an encoded variant of the original malware, while the metamorphic code rewrites itself entirely, creating countless unique variants that are difficult to detect with some signature-based scanners. Okay. And next, like living off the land. So this is a technique where the attacker uses some legitimate system tools like the partial already present on the system to execute some malicious operations. So this helps the activity blend in with the normal system processes and bypass the security software. Okay, so these are the techniques in file obfuscation, but apart from that, we have so many techniques that is used, right? As we have discussed, like compression packing or the string encryption or the encoding, all such cases, right? And the common use cases that is used, like first one, mobile app development, like Android and Flutter, developers, they use obfuscation to protect their apps from reverse engineering and preserve their source code. Okay. And second, like data security. So data obfuscation can protect some sensitive information in databases by obscuring the original data, by making it useless to attackers even if a breach occurs. And next, like in case of network security, some systems may obfuscate file names in our network transformers to prevent them from being easily identified or manipulated, right? So that is why these are the common cases in case of file obfuscation. And next is that we will discuss about what are the general differences between the binary and file obfuscation, right? So the first of all, the exact definition of it is which making compiled executable code difficult to analyze or reverse engineer. And in file obfuscation, making any file type difficult to identify, analyze, or understand its true nature, right? And second, like the target scope, what is that it has some executable files, right? And here, if you take like any file type like document or the images, archive, executables, which is done as a scope. And here in primary purpose, like it prevents the reverse engineering and protect the intellectual property and hide the algorithmic logic and anti-tampering, control flow obfuscation, and anti-debugging measures, right? And so these stuff, comes under. And whereas if you take in case of file obfuscation, it evade the deduction system and hide the file contents and bypass the content filter. And next one, conceal the data exfiltration, right? And what are the main techniques? Like if you take here in binary obfuscation, here it uses some control flow packing or encryption and instruction substitution and virtual machine protection and date code insertion. And here also similar to that in file obfuscation also we use some file format manipulation, encryption or the encoding, and next technography and header modification And next, like extension spoofing and archive nesting, right? So all these stuff, we have already seen in the obfuscation video. You can just check out that video, because in that video we have clearly explained these techniques and the primary purpose and why we are going for it. So once you have a thorough study on that particular video, you can be an expert in this particular session, right? Can you able to understand? Okay. Yeah, okay. So these are the differences between binary obfuscation. This is the file obfuscation, right? And now we will discuss some of the examples for this file obfuscation. Consider a malicious script like hidden within an image file. Say in Python, we are writing like greet of world and original like unobfuscated, like define greet of name, we are passing and print the name, right? But in file obfuscation example, the script could be encoded, like example page 64, and then embedded within the metadata or pixel data of an image file. A separate small loader program would then extract, decode, and execute this hidden script. Okay. For example, like encoded string, some like embedded string is given, and we are loading the program like import base 64, right? And extracted data, we are giving like encoded script. In a real scenario, this comes from an image file. Okay. And similar to that, in decoded script too, I'm providing base64.b64 decode extracted data dot decode of UTF-8. And while you're printing this kind of stuff, right? So that the some error rises, because if you're going for this kind of obfuscation, once you're using some techniques, the main purpose is to control flow, but that was not, so automatically this will be hacked by the people. Okay. And next, similar to that, there is also some, avoiding some any recurring pattern in the obfuscated section. You can go for like one-time padding. Like one-time padding, they are the keys, that long as the data is encrypt generated by the genuine random number generator. Yeah, the idea is to have some pool of random numbers so that they use to encrypt your data. If such number has some enough randomness, then there are no recurring patterns, and the reverse engineer has no repeated data which can use to break your code, right? So these all the stuff. And having this one time pad can be mean to manage. It all depends on what you have to protect and how much time you can dedicate, right? And maybe selecting a longer key can be enough for us. So imagine using some part of your own application key, right? A text section that will be changed by the loader during the relocation. Okay. And next, like smart obfuscation. Well, not really so smart. So this, let's try to resume what we encountered during a previous test using XOR encryption that will lead to some binary obfuscation that avoid the automatic scanner or to search for a binary stream that can lead to the detection of your technology. On the other side also, this base encryption is easily detectable and decrypted by a reverse engineer that takes some time when reading your application. Okay. So by means of text, the section and classification also will be done. So, well, if you want to use some shipper code, you're free to do. I usually test the code during some thing, right? But here, like a binary project, also you can also jump the output in a log file to compute the steps of what has to be done, right? So applying some multiplied key will make it more challenging to, describe some engineer versus engineer. So you can have some 512 byte key that repeats after having some encrypted 512 byte of a binary code, right? So these are the common techniques has to be followed in application. Okay. So in this session, we have discussed on the topics. So what is meant by in general obfuscation, and what are the types like binary obfuscation and file obfuscation we have discussed. So in binary obfuscation techniques, we have discussed so many code transformation, data obfuscation, structural obfuscation, and anti-analysis technique. And similar to that, in file obfuscation also, we have discussed the categorization of it and techniques to be followed for the file obfuscation, right? Like disguising the file, type in the appearance, right? And the code as well as the data obfuscation, okay? And as also we have discussed about something like evasion and anti-analysis techniques, right? And then the last slide, we have discussed about the differences between the binary obfuscation and the final obfuscation in terms of definition or the scope of it and its purpose and what are the main techniques and what are the real-time applications, right? I hope you all had a very good session about this obfuscation techniques in this video. Hope it will be very useful. We will see you in the next video. So thank you all.